Okay. Hello, everybody. It's quite late here in Los Angeles. It's about 10 p.m., 10:15 p.m. We are going to wait maybe 5 or 6 more minutes before we get started. In the meantime, my name is Randall. I'm a software engineer at AWS. I work mostly on building demos for our services and not so much on coding the services themselves, although I have done a little bit of that as well. And for those of you who are new to Twitch, the way that this works is you're going to help me code something live. So what I'd ask you to do is, hop on into the chat and kind of be a part of everything. If you have a suggestion, if I make a typo, let me know. Don't be shy. I'm monitoring the chat. I'm happy to name random variables after people. Earlier today, we named the whole project after Krish. Thanks again for coming a little bit earlier. And hello to some of our new users, Hey Soul and Labnol, welcome. And hello to some old friends, Toasted Quinoa had to go to bed. And I think we are all set. So let's get started. Today what I want to talk about is AWS SageMaker, or Amazon SageMaker. And what SageMaker is at its core is a machine learning pipeline. And what I mean by that is there are a couple of different core components that really make it powerful as a tool. You have your notebook instances on one side, which are where you kind of do your development and hacking and tweaking of different algorithms and different kind of hyperparameters. Then you have the job section, and this is the training section where you can submit the graph or the network topology for your network that you've defined and say, I want you to run this across n number of instances and pull the data from S3 and then create a model that you output back to S3. Then there's the model hosting section. This is really just a definition of where the artifacts for the models live. And this is really only useful in conjunction with the endpoints. And the endpoints are some of the most fun that you can have with Amazon SageMaker. What you do with the endpoints is you actually take those models that you've trained, and they don't even necessarily need to have been trained in SageMaker. They could have been trained anywhere. So you could bring your existing models into this platform very easily. You take those models and you kind of move them into one of these hosted endpoints that's auto-scaling and can do A/B testing on different variants of the models, and you're able to serve real-time inferences from those different situations. And JF Mario 87 asked if I can help with a Russian bot that I'm trying to build. Well, I don't speak Russian, but we are going to build a Twitter bot. So I hear there are a lot of Russian Twitter bots out there. But this Twitter bot will actually be useful instead of boring and annoying and trying to spread Ethereum scams. I don't know if anybody follows Twitter. So yeah, I seem to be a bit overlit. That is entirely my fault. And I don't really have a good way of fixing it. So we're just gonna have to deal with it. Sorry. I think I could probably turn down the brightness a bit. That might help. Is that okay for everybody? A little bit better? How's the audio? Everything good there? All right, great. I'm also extremely, I need to get more sunlight, which is why when I'm overlit, it's impossible to see me. Getting back to our situation at hand, the first thing that I'm going to do is I am going to create a notebook instance. And I've actually already created one of these, but for the purposes of this channel, we could say, hello world, or if you guys have a suggestion for what we name this notebook instance, I'm going to call mine not serverless. We're going to launch this notebook, and what this does is it kind of directs us into a Conda environment. This comes with a bunch of different sample notebooks. There is, in addition to all of the cool features that I just talked about of running the notebooks, running the training jobs, a set of SDKs that are available for in Python for SageMaker. And also there's a Spark connector if anybody wants to connect to EMR and stuff like that, but I can talk about that a little bit later. And this Python SDK actually makes it really, really easy to run and train any kind of notebook McNotes face. Yeah, we're definitely gonna call it that. You sold me. Notebook McNotes face. All right, this is our second notebook for later. This Python SDK makes it really, really easy for us to define a very simple method called train that we then kind of invoke. And the way that this works, you can see it on GitHub. It's not, you know, top secret code or anything like that. You can go and look at the AWS Python SDK or the AWS SageMaker Python SDK. We can go and look at the source here. You can see, for instance, for predictor, maybe not for predictor. Let's go to MXNet and estimator. Not even that one either. Let's go to estimator in this one. Awesome. So this uses some really cool Python features. This is, in my opinion, some of the most fun Python code to go through if you guys like kind of diving through source code. It uses a meta class to kind of enforce on the underlying implementing class what kind of stuff you should have. And you can see you have these decorators like abstract methods. So this kind of harkens back to Java, and it tells you how your images and everything should work, how your system should work at its core. All in all, really, really powerful SDK. I encourage you to check it out. But one of the things that it makes really easy is taking a common machine learning problem, in this case, something called MNIST, which is a group of 10,000 different handwritten digits that we can train a network to learn to recognize. And then when we pass in other handwritten digits, it should be able to read those. So I did this demo earlier today. I'm going to kind of rush through it because I think people feedback earlier from today was, and yes, this will be downloaded for future reference. So Ayush has asked if this will be available for future reference, and yes, it will. All of our stuff is published to our YouTube channel, and it'll also be available on Twitch for a period of time. So I have this MNIST notebook, and I have my MNIST data. But before we really get into what all of this is, I thought it would make sense to kind of talk about what machine learning is at its core. And way better than me to explain this is somebody named Grant Sanderson. So there's this guy, 3 Blue, 1 Brown from YouTube, who has a whole series on what are neural networks and how do they work. And I'm not going to show you the whole series now, but I will send a brief message into the chat so that you guys can all see it. And Grant was kind enough to let me use some of his animations, which I think really kind of explain the MNIST problem very well. So first, we'll take a look at the code. This load data section, all it's doing is it's just kind of unpacking this tightly packed structure and basically creating an array, kind of a NumPy array, of 28 by 28 pixels with grayscale values. Now, this is the really important part here, this build graph section. This build graph section is where we define the topology of our neural network. And what we're saying is we have our input that we're flattening out. So instead of being this 28 by 28 pixel section, it's actually going to be this 784 by 1 section. So instead of this kind of square thing, we're flattening out all the pixels and putting them into a box or into a line. The next thing that we do is we create this fully connected layer. And now what that means is every node in that first layer, those 784 kind of neurons in our first layer, are going to be connected to all 128 of the neurons in our second layer. Then we have an activation function that we define connecting those, and that's going to be ReLU, which is a rectified linear unit. You don't really need to know what that is. I'm going to throw a lot of words out here, but just know that it says, how active does this neuron need to be before I decide to activate? What value does this pixel need to be before I decide to activate this neuron, essentially? And then I have a second layer, which is num hidden of 32. So I go from 128 to 32. These are kind of arbitrary values. So I could go down to 64. I could have 2 layers of 16. And I'm actually going to leave it at 2 layers of 16 right now, because what I'm going to do is I'm going to show you some animations from Grant about how all this works. And hi, Techie Adarsh, welcome. Thanks for joining. And this last fully connected layer, what it's doing is it's saying, let me take in all of those other components that I have, and I want to kind of choose a digit between 0 and 9. So that's 10 different neurons that we basically use to select the output of this network. So that is what the network looks like. Let me show you a brief video of how this works. So again, we have 784 pixels as our input, and then we are defining another layer with 16 neurons in them. Pardon me, I'm a little bit parched, so I'm just going to have a quick sip. So we take those 784 pixels, connect them to 16 nodes, connect them to another 16 nodes, and we end up with 13,002 different kind of values that we're going to be adjusting. Now, it is perfectly normal to go and just initialize these different weights and biases with totally random values. And then what you do is you kind of back propagate from what the result is into changing these weights and biases to get the result that you wanted. So to do that, you basically define a cost function, which is how far off from the desired answer was our answer. And we can do this repeatedly. It's embarrassingly parallel, so we can do this across pretty vast sets of compute nodes. But luckily, this data set is quite small, so we don't really need to. So, and the Chad 314, I like the 314, it's the first little bit of pie, is asking if the 16 nodes is arbitrary. And it is arbitrary. So I actually think that 16 is probably not even optimal, right? Because we're going from 784 values all the way down to 16 values. That's a pretty small, that's a pretty vast change in magnitude right away. And then we're doing another layer where we're getting the same kind of resolution. So 16 by 16, maybe not the best choice. What might be better is to go from like 128 to 32, or even down to 16, you know, to move in smaller increments. And Kuvin asks, how many layers is ideal? And that's going to change depending on the problem. You could delete this entire second layer. We might not need it. We could go straight from 128 to 10. And we basically learn how to build these networks based on experience and trial and error. So once you've built a few of these, and they are quite easy to build, you can run all of this locally. You don't need to be spinning up a big instance or anything. It runs just fine on your laptop. You kind of get some sort of intuition for how these networks should work. Typically, and again, this is different for different kinds of problems. Typically, you want to try and move towards smaller and smaller numbers in the layers that are closer to your output. So if you're doing a binary choice in the end, you want to move towards lower and lower numbers in each of the layers. And adding more layers doesn't necessarily cause the network to learn any better. So, you know, you could have thousands of layers that are programmatically generated, and actually plenty of models work like that. But for this particular problem, you might not get any better result than you would if you had just this simple 3-layer network. So the next thing we want to do, and this kind of answers, there are a couple of questions here. So how do you decide the correctness nodes? Are they just random? Is from Diptyam Dutta. The initial weights are typically kind of randomly assigned, but then what you do is you go through this process of training and back propagation. So you take the data that's you have labeled from this handwritten digit data set, and you basically split it into 2 parts. You have a training data set and you have a test data set. And the reason you split it into 2 parts is you want to make sure that the training data set isn't just being memorized. You want to make sure that it's actually being that it's actually learning to recognize characteristics and stuff, rather than trying to just pick up and memorize the data set. That is a real problem that people have. So what they do to try and prevent that is they actually shuffle the data set around, and they will do different splits of the data, and they'll rotate things. They'll do everything they can in order to generate as much data as possible to kind of throw off this idea of memorizing the network or memorizing the images. And then we define a batch size. So this says that we'll run 100 different training, 100 different samples through at once. We create 2 different iterators. And you can see I have shuffle as true here. The first is the training iterator, then there's the validation iterator, just some logging stuff. And then we say whether or not we're going to do this as distributed, or if we're going to keep it all local. In this case, we're going to keep it all local. And then we basically define our module. And the way that we do this is we just call out to mxnet, mx.mod.module. We build our graph by calling our build graph method. We get our context, which is the number of CPUs and GPUs that are available to us. And I think that's defined somewhere. Then we just call fit, and that fit takes in our training iterator. It takes the eval data for the validation iterator. It says if we're running locally, and then it has an optimizer. And this is the stochastic gradient descent optimizer. And I could put in Atom as another kind of optimizer. Doesn't really matter what we use here. It's going to be just fine. And then we can pass in different parameters like the learning rate. One of the really cool components of SageMaker is it actually has for many algorithms and not for this particular because we're kind of defining it ourselves here, but for many of the algorithms that are already defined with SageMaker, it will do hyperparameter tuning and optimization. So it can run multiple runs simultaneously and kind of adjust your learning rate or other different kind of optimizers for you, a number of epochs, things like that. Then you can change the number of epochs. We'll train for 25 epochs, and we'll return this model. And that's really all we need to do in order to get this working. So that is the core of the network. I'll show you one more video briefly, just for those of you who have some questions still. So a neuron is essentially a function. Is not a thing that holds a number. It's actually the function of all of these input weights that we are taking in, and all of the kind of different weights and biases that go into that. And we basically combine these functions and execute them in order to get our result, which is a confidence value of which one of these, 0 through 9 digits we think is most likely. So pretty straightforward. We have a couple of questions on the stream, things about Microsoft Tay. I don't actually know what that is. I think that was like a chatbot that they built that had some issues with trolling, according to you guys, but I don't know. And then we have questions about, is Python okay for scaled solutions or Scala to be used? Python works just fine for basically any problem. Scala also works great. And any best practices from Ghostwriter, and any best practices to decide number of nodes in each layer and number of layers in the network. And again, you want to trend towards your output. So typically you want to go for fewer layers. Now, there are exceptions to this rule. You want to go for fewer nodes in each subsequent layer. Now, this is just one type of network that I'm describing. There are a number of other kinds of issues that you have to deal with. And then Ayush 3112 is asking, what about noise? And I think you mean noise in the image where you don't have perfect grayscale values. So typically you do a little bit of pre-processing on the image, which is something we'll talk about a little bit later. And the way that you do that pre-processing is you can kind of say, hey, I want to just do edge detection, and I want to like grayscale this whole image, and I want to zero out any values below this threshold, stuff like that. And you can do like noise suppression gates and stuff like that. So what I'm going to do is I'm actually going to start this training. And you can see I've just defined a couple of different things over here. This is the file that I just showed you, this mnist file. And then I'm going to basically define by importing mxnet from the SageMaker SDK an mnist estimator. And I'll say output this to the model artifacts location. And then the code location is going to be whatever custom code location upload that I said. I'm going to train this on a single instance. I could train this on 10 instances if I wanted, but given that it's a very small data set, there's really no advantage to that. For much larger data sets, you see that kind of benefit of the parallelism go way up. So I'll run all that, and then I can actually run the training. And if we hop over into SageMaker and we hop over into this jobs section, you can see, you know, I had these other jobs that ran earlier in the week and earlier today even, and now we're training this other job, and you can see it's got all my input. It's saying, you know, where's all this going, blah, 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 blah. Kind of useful, cool stuff. You can see the logs from the training. There won't be anything yet. Actually, it'll be, let me look at one that's already completed so you can kind of see those logs. Sorry, my throat is So these are the runs that I did earlier today. I did a session earlier this morning, India time, and about mid-afternoon for me. And again, very, very straightforward. It's just kind of like taking input from one location and running through the training. And that's how machine learning works. It's really cool and powerful. And some people are recommending that I not drink Coca-Cola if my throat hurts. I am also a machine learning, so I am a machine that takes Coke and outputs code. Coca-Cola, and that's a joke. Sorry, that's just a really stupid joke. Yeah, you're exactly right. I probably shouldn't be having Coca-Cola, but it also has caffeine, which is useful at 10 p.m. here in Los Angeles. So this is going to run for a while. I'm not going to make us kind of sit around and watch this train, because it's not exactly the most interesting thing in the world. So I thought that we would look at how we could build a little bit more fun bot. So there is this paper from Berkeley that describes how they built a network to rival the Planet network that I think Google built. And what they did is they took the Berkeley Multimedia Commons dataset, and this is 100 million geotagged images from Twitter. They took that data set, pardon me, really need some water or something. They took that data set and they used it after they cut the Earth into grids of about, I think, 10 meters by 10 meters to guess where in the world things were. So they took the geotagged images and did various kind of problems to try and various kind of like work to guess where stuff was. So this is saying very confidently this is in New South Wales. So if you guys have any pictures of your current location, I thought it would be really cool for people to kind of tweet at this bot, or I can build like a little S3 page during the session that you could upload pictures to, and we can try and guess where in the world you are, and we can see if we can do better than the bot. And this is based on a paper from Berkeley. A lot of the code that I'm going to be using is directly from their paper. I am not a particularly accomplished machine learning expert, so all I am really qualified to do is take some of this stuff and kind of build from it. So now we are actually ready to start coding up both this model and how it all works. But before I do that, I need somebody to tell me a name. What should we call this project? So while you guys are doing that, coming up with a name and voting on it, I'll just hop back over to this endpoint section. And Sri Lola, I will share the GitHub link at the end. And I'll also make sure that it's posted in the session details for those of you who are attending the live day. So does anybody have a name that you want to call our little project today? I will accept something, mix something. That was a good joke, whoever said that earlier. MKDIR. So we're going to call it Quang. And the only reason we're going to call it that is that Ferrari is hard for me to spell. Oh no. Oh, body make bot face. I like that better. dir body make bot face. Great suggestion. That's what we're gonna go with. Body make bot face. I'm actually gonna do this one other time. Body make bot face. There. With the proper capitalization this time. And so we'll get started. And for those of you who went over to this Twitter bot, if you want to see the results, you basically need to click over into tweets and replies. Oh, it looks like somebody uploaded a picture here. And it seems very confident that this was in Washington or Montana or Oregon. It kind of looks like Niagara Falls to me. I don't frequently do better than this. But yeah, body make bot face 1. So thank you guys for the name suggestions, but this is clearly the best. Thanks to whoever suggested that. I think that was, I'm sorry, I already lost you in the chat. It's scrolled past. So this last section of SageMaker, which is the endpoint hosting section, is kind of the fun and cool part that I really like playing with. Basically, it spins up an API, a TLS security API that I can invoke by just making a post request to this endpoint here. So what I have highlighted, I can go and I can say, hey, tell me where something is. And real developers use rm-rf when they don't need to. No, I'm teasing. It's a terrible habit. Don't get into that habit. Oh, cool. This finished. Oh, it didn't finish. Never mind. But it's almost finished. And then when that's done, we're gonna create an inference endpoint, and then we'll run everything else here. Anyway, so I'm gonna keep this data open just because I need it to kind of get stuff done. First thing I need though is this grids file, and I kind of need the raw version of this file, which is not loading. I feel like I've crashed my browser by even clicking on it. How do I undo? A terrible choice. Okay, well luckily I have this on my local machine, so I'm not going to try and download it. SageMaker grids. So I have this grids.txt file, and we're just going to open up the notebook and kind of steal some of their code to define how all of this works. So I also already have the model kind of uploaded in S3. So I've defined it already. And if we go and we look at how SageMaker takes our own model, there's this kind of interface that you can take a Docker container and post up to SageMaker, and it will, oh, that's not the right Docker. And it will tell you, what kind of interface you have to adhere to. So you can see here, I have to have, an entry point, and I have to respond to port 8080 and to /ping on port 8080, and then I have to be able to take post request on this invocations endpoint. Pretty straightforward. These are the only 2 endpoints that I need. So if I go and I just create a very simple app.py, real quick here, we can make this work. So we can just say import Flask, and then app equals flask.flask name. Well, actually, we'll call this body make bot face, and then we'll define a couple of routes: app.route ping, /ping, and let's see. This really just needs to return a 200. and it's an empty body. I don't need to return anything in it. And then I have my other route, which is going to be my invocations route, /invocations. And this is going to be, I don't know if this is capitalized or, I think it's like this. And this is just going to be a post request. So other kind of methods would be invalid. So invoke. And for now, we'll just pass. And that is essentially our entire app. We don't really need to do much more than that. And then we need to create a Dockerfile. So I'll create the basic Docker. Oh, yeah. I'm trying to tab complete to a file that doesn't exist. So Dockerfile. And I'm actually going to use an existing image here. I'm going to say from mxnet/python. Latest is going to be my base image. Where was Quarg's lowercase? What did I do here? My Vim color scheme is solarized. I've always thought about making my environment a lot more boring because that's the only thing people ever have questions about. Oh, I also need to do like an easy way to make this run. App.run host equals 0.0.0.0. If you guys are running your own Flask app inside of one of these, you might run into the issue of the host isn't responding, and it's often because you don't define the host, so it's just listening on localhost, and there's some weirdness with Docker that happens where it doesn't go through. Good call, JF Mario. And MSP997 asks, what are we doing? We are building a Twitter bot, and you can see the Twitter bot here. And what it does is you post a picture of something, and it tries to guess where in the world that picture is. That's basically how it works. So then we have a Dockerfile that still doesn't exist. Oh, it's in this other tab. And the Dockerfile is really, really straightforward. Basically, I'm going to create a working directory /app, and then I'm going to say run pip install -u Flask. Don't really need anything else right now. And then I'm going to say copy all of the .py files into /app/, and then maybe like copy grids.txt and do /app. And you would typically put all of this in like one line because each one of these is like another layer and all this stuff. And then we have an entry point that we define. And this entry point is going to be Python in this case, and then app.py. And then we just say expose port 8080. And then we can say docker build -t dot and it'll just build, and ta-da! Like, not super complicated, pretty easy. And then we can kind of upload that to ECR, and then we can actually start just posting stuff. Now, it tells me over here in the using your own algorithm section that it's going to upload my model into /optml model. And everything that we've defined so far has just been like the basic schema. We haven't actually built any of the underlying code that does our inferences and stuff yet. And this kind of code is actually a little more complex than what I went over previously. So I'm going to copy and paste sections of it from this Berkeley Multimedia Commons tutorial here, just because they're better coders than I am, although they're not particularly good at PEP 8. Not that that really matters. So we are just going to get started. So I'm going to make a new file called predict.py. And in this file, I'm going to import mxnet as mx. So I'm going to import numpy as np. And then I'm going to use scikit image to kind of skimage. Can never figure out if I'm spelling this correctly. Transform. And then MSP997 asks, are SageMaker and Spark the same? They are not. They are complementary. So you have a Spark connector that can allow you to trigger SageMaker jobs as part of like a Spark ML pipeline, and also to pull data from Spark, or use SageMaker as part of a Spark job, stuff like that. And then we're going to need import URL lib. And then typically I put the like real Python libraries at the top and the not real stuff, which is like the third-party libraries at the bottom. Oh, and then we're going to need also from collections import named tuple, which I think is just about right. Okay, so I'm going to define a few things here: arg params, and then auxiliary params equals mxnet.model.load checkpoint. Somebody asked, is mxnet the same as TensorFlow? It's similar. It's not, I wouldn't say it's the same. They're both frameworks that you can use to train. I think that mxnet is a little bit higher level, so it's a little bit more abstracted than TensorFlow. You don't have to know quite as much about the underlying math to make mxnet work. And mxnet also typically scales better in terms of like parallelism. That said, you really can't go wrong with TensorFlow. You can't go wrong with mxnet. So, you know, use the stuff you know best. And the other thing I'm going to do is I'm going to import OS, and I'm basically going to define two different things here. I'm going to say model path equals os.get. And yeah, Keras is awesome. And Keras can actually interchangeably.
Sorry, I'm not sure.
That's my Alexa. Keras actually has interchangeable backends, so you can use either TensorFlow or mxnet. We're gonna just say get model path, and then I'll just pass in kind of like the default path here, op/ml. Well, I have to look it up again one more time. op/ml/model. And then I'm gonna have model name. It's gonna be os.getInv model name. And in this case, I'm using the model that they have, which is this RN101-5K. So RN101-5K500 file. So I'm pretty sure mxnet Keras. Yeah. So yeah, you can run so Sonus Singhal, you can also run mxnet as a backend in Keras. So Keras is pretty cool because you can basically run whatever backend you want to run. So we want to load the checkpoint from our model path plus model name. And then we're going to load this kind of 12 here. And I just know this from experience. And that's just saying load the end of it. Come on, why is this not? Okay, and then we're going to create a module, and we're going to say mxnet.mod.module symbol equals sim, and then context is going to be CPU. We're not training here, so we don't really need the GPU, so we could call GPU here to get the GPU context of this machine. We don't need to do that because we're just doing inferences here. If you're training this network, the GPU does help. I have actually trained this network with kind of like a rudimentary version of what was implemented in the paper, and it takes a long time. So mod.bind, and then so we'll bind to data, and then I know the shape of the input, so it's basically like these RGB values and then 224 pixels by 224 pixels. Close that out, and then I think I messed this up here. Close that out. Now I can go and say for training equals false. And then I just say mod set params, and these are just the params that we got from loading the network. And we're gonna say, and thanks to Chad and sauced up. I don't know. Strange people. Arg params, mod.set params, aux params. Those are again just the checkpoints that we had from earlier. We're going to say allow missing equals true. And now we're just going to define kind of some basic arrays that we will use to mean that data out. 1.368. And I am copying this kind of directly from here. So it's literally the same code. So 123.168, 116.779, and 103.939. And then I'm just going to call reshape 311. Oops. So that's our mean RGB. And now we need to create a batch. This is just going to be a named tuple, which is like our fake little class here. And then this is just going to be that data variable again. And then we need to create our grids. And again, this grid stuff is just kind of copied from here. So I can literally take the whole kind of set of code and grab it from there. So grids is going to be this empty array, and then we just import all of that grid data here. Now we're going to define a couple of different methods. And some of this is taken from here, but a lot of it we're going to modify pretty heavily to make it work for Twitter. Just because the Twitter API is a little bit, it provides its images differently than just like being able to download a random image. And we have to make some modifications to some of the URLs and stuff like that. So the first thing we need is just this very simple download image kind of URL format. And we'll just create a file descriptor. Oops, 1234 fd equals urllib.url open, and you could do this with requests too. I'm just using urllib so that I don't have to install yet another library. And then image equals io.call plugin, and this is going to be mread, and then we're going to say open that file descriptor, and then we're going to use the plugin of the Python imaging library, PIL. And we are using a Jupyter notebook. But that's all like done and working now. So, you know, I could draw a digit here and it will very confidently tell me what it thinks it is. The most likely answer is 8. It also had 9 with 5% confidence. So let's try this again. Most likely answer is 4. I feel like I have a off by 1 error here. So if this tells me it's 2, most likely answer is 7. Okay. 1. Most likely answer is 1. So at least it got 1 right. Let's try this once more. Most likely answer is 7. So I mean, this is just that model that we built earlier, and this is calling. I mean, basically what this is doing is you can say import photo3 SageMaker equals photo3.client run SageMaker.runtime, and then SageMaker.invoke endpoint and then body, you just pass in, you know, whatever data you want to try and like pass in. And if you want to do 0, most likely answer is 5, and it was very confident. So obviously, like, this wasn't the most well-defined network that we did. We can kind of see like how well it's doing. You know, it's saying that it's got an accuracy of 99%. That's obviously not quite that good. We could apply one of the existing SageMaker algorithms. So we could go back over into the sample notebook section, and you'll see there are a number of like pre-trained algorithms, or not pre-trained, like algorithms that Amazon has built specifically for running on SageMaker. So there's this linear learner, for example, and this you basically just point it at the data, and it'll do kind of all of the stuff for you. You don't have to define that train method that we defined earlier. So if anybody remembers from earlier in the stream, we were talking about how this train method works and how this kind of build graph method works. You don't have to do any of that. Basically, you just say, here's my data. I want you to do this unsupervised learning and figure, well, this linear learner is supervised learning, but you can point it at raw data and do like k-means stuff, and it'll just work. I'm sorry the audio and video is out of sync. I don't really have time to fix that right now. I will try to fix it in post. Pardon me. So yeah, I mean, maybe we'd do better if we had changed this from 128 to like 16 and 16, or if we changed this from ReLU to like Sigmoid or TNH or something. There are all kinds of different things that we could do to make this work a little bit better. But we're kind of done with the MNIST section now, and we're gonna try and stay focused on this getting the components of this Twitter bot done as quickly as possible. And in the interest of getting this done as quickly as possible, I'm going to be copy pasting some code, just because I know not everybody wants to sit here and watch me type a bunch of like complex math. So I have this preprocess image method, and all this is doing is it's just taking the input and cropping it and resizing it in order to get it into the shape that the network is expecting. And then I'm going to define a predict method, and this is, oops, sorry. I'm not in the right tab. Can you guys see near the bottom here? Predict. So this predict section is where we're going to do the work. So basically we've defined our model, we've pre-processed the image, you know, this is what we're expecting to get. So we're going to call mod.forward. And this is going to say run, you know, my image through the network and give me an inference on it. And then I'm going to say probability is going to be mod.get outputs. And this is actually a really, really big array of like grids and confidence values that I get back as numpy. If I were in the notebook, I would show you with kind of an example image of how this all works. But in the interest of time, again, just because I do not have too much time left, we're going to skip that. And then we're going to make our prediction from this. So we'll say mp.arg sort by the confidence value. And then we'll reverse that so that the most confident is first. Result is going to be empty array, and then for, I guess, I in range max predictions. We want 1, 2, 3, 4, 1, 2, 3, One of the worst parts of Python, I do love Python the language. I think it's really well designed, but white space as the delimiter is just, it's a choice I disagree with, to put it mildly. But at least it's not JavaScript. Anyway, predicted location is going to be grids, and that's that grid section that we defined a little bit further up. So we're going to say grids is going to be, int of prediction I. This is going to be our predicted location, and then we can really just say results.append. I feel like I'm doing this incorrectly here. So I think I can just say predicted location. So I could have done this with the list comprehension or, you know, whatever else. If I wanted to include the confidence values, I could include those pretty easily as well. So I would just basically get the probability from this. So I would say, you know, the probability is, you know, pred I, and you know, I could put that in the results as well, but I really don't care about the actual confidence value. All I care about is like the predicted location. So let's see. I think that's really all we need to do for now. So return results, return result. And then I'm gonna have one more that just kind of combines all of this together and runs it for me as like one convenient little method. So I'm gonna say download and predict. And this will take a URL and a max predictions, in this case 3. And then we're gonna say image equals pre-process image download image URL. And then return predict image max predictions. And that should work. And we can kind of test it out here. We can run it all locally. Oh, I have to actually, did I spell append wrong? It's very likely that I spelled something wrong. So Nitish has said result append. Oh, good call with that S on the end. Nice catch, nice catch. Thank you. So yeah, over here in this app.py kind of situation where we had this invoke method earlier, all we're really gonna do is just say, you know, data, why is this not working? Sorry, data equals request, oh crap, I need to import request from Flask. And I never even imported from Flask. I normally have Pep8 and like Flake and stuff turned on when I'm coding, but I turn it all off just because it makes the screen go crazy when I have it zoomed in so much, so it's easier to see. So that's why you don't see an easier version of this. So from Flask import request, and also JSONify, because that's what I'm going to return in the result. Actually, in the meantime, just to make sure this is working, what I will do is I will open up a Python interpreter. I will import predict. Why is that invalid syntax? Anybody know? Oh wow, I never closed this. I never closed that. Weird. So I'm just gonna open up a Python interpreter really fast and make sure everything's working. So does anybody have an image they want me to try? Failed to open /opt ML model. Oh, I see. So let me just put a slash there. Yep, I'll fix that JSONify thing in a little bit. Cool. So I'm just gonna look up an image of a random location. So somebody in Twitch chat say where in the world they are. And I will look up an image of that location and we'll see if we can correctly predict. I absolutely love this name of Body McBotface. You need to be more specific than like India or Seattle, like name a town or a very like small place. India is very big, so I could post anything from India and it would likely be right. Okay, Jog Falls, Bangalore. So I'm going to take one of these that's already pretty close to 284 pixels. That's not right. I'm just going to take this first result. Come on. I wish it would like let me copy the URL directly from this page. Copy image address. So if I go here, okay. So now if I go download, predict.download and predict, and I pass in this URL, we'll get some results. This is the first result, and we can just go and put these coordinates into Google Maps, and it will very incorrectly tell us some place in South America, it looks like. Yeah. Okay, interesting. So it's very confident that this is actually in South America. So I'm thinking we might be able to get this to work. So here, what we'll do is we'll do predict, download, and predict, and we'll actually start with a much higher resolution image. I'm pretty sure this is just the same resolution, but we'll actually say a much higher number of max predictions. So max predictions is going to be 10. So this looks like it might be a little bit more our speed. It's on the right hemisphere. So this is saying it's in Burma, which I don't think is quite right. So maybe this one is a little more accurate. And this is where those confidence values come in handy, because it's probably got like 5% confidence for all of these. And I don't think this is in India either. Also in Burma, Myanmar. And I'll try one more, but doesn't really look like it's any of these. Maybe it's this one. This is the last one I'll try, and then we'll move on to continue training. Okay, well, we tried. So do you want me to try this last one here? I don't think it's on Sri Lanka, but I could be wrong. Anyway, oh. That's about the fourth to the last one is correct. So this is the last one, this is the second to last, the third to last, this is the fourth to last. So this one is correct. So is that correct? Ooh, not that one. This one? Okay. I promise we're gonna get back to coding. I like for the algorithm to be right sometimes. That doesn't look right either. No rocks. Okay, unfortunately we gotta move on a little bit, so gonna keep going. So I've got to make a couple of little updates to this app here. Then, so JSONify, and I'm also going to need to like import predict, and I don't really need to do anything else for now. I could import, you know, logging and stuff like that, and I could mess around with all that, but I'm going to ignore it for now. I'm just going to call request.getJSON force equals true, and this will say even if the header doesn't match JSON, I want you to try and coerce this data into JSON, and then I'll say results equals predict download and predict data URL, and then int max predictions. Sorry, data max predictions. I'm going to do this differently. Get max predictions or 3, and close all that out. And then I'm going to do return JSONify result. Geoguessr. What is Geoguessr? I have never heard of that. This could be awesome. Does this use like Google Street Maps or something? Okay, so if I just take a screenshot of this. Well, see, this isn't going to work as well because this data is kind of like artificially constructed. So this is like a bunch of images that are like they've already been reshaped and stitched together. And like the network wasn't trained on images like that. Let me see. Let me get one more picture here. So that's pretty cool. I hadn't thought to do that. So I could, you know, import SciPy, and where do you guys think this is? I'm going to say this is in rural North Carolina. Completely wrong. This is in Norway or Sweden. Wow. I am not good at this game. But basically I can kind of take that image and run it through later. That's really cool. That's a really good idea. So Donero had the idea of kind of incorporating with Geoguessr and maybe training it that way. That's brilliant. If they have an API, I might stay up all night and like build that now. Wow, good idea. Good idea. Where were we? Sorry, I kind of lost my train of thought there. So I think that's the app. So if I go python app.py, that should work. Should. Yep, working, more or less. And then I guess it's still working. Huh. That's weird. How is this still running? Okay, better. Where were we? Dockerfile. So then I can do, in the Dockerfile, I'm going to have to include a couple new things here. So I'm going to need to include that scikit image stuff that I installed a little bit earlier. So scikit image, I'm going to need to include NumPy. That honestly should do it for now. So then we'll say docker build. This will run for a second, and then we're basically going to upload this image to ECR. So to do that, I have to log into ECR, which requires executing this command. And that just kind of does all my credentials for me. And for those of you who are not familiar with that, it's basically backtick say, I want you to execute the output of this command. No worries. This is still building. I probably should have named this. So, does anybody know how to list all of my images? I don't actually know how to use Docker very well. So really all I'm doing here is trying to get Docker image ls. Wow, I have a lot of images. And I probably should have named this. So if I kill this build, what happens? So if I go docker build-t body make bot face, does it name it body make bot face? It does. So this is like a 2 gig Docker container, so it's going to take like a hot minute to kind of like upload. So I mean, in the meantime, I can kind of answer various questions, but what I'll do is I'll actually go and talk about the Twitter API. So the Twitter API, which is what we're going to use to build our little Lambda function that talks to all this, it works in 2 kind of primary ways. There's the streaming API, which you do, you basically invoke the streaming API by calling a long polling connection that says API.get user stream. And this will say, you know, anybody who mentions me, anybody who follows me, I want to get some sort of data about it, and then I want to respond to that tweet. The downside of this API is that you have to have a server or like another container running in Fargate or something running all the time in order to consume the input. And there's no real reason for that. Like almost all of this could be done much more easily with their webhooks API. So they have this new API that I really like that is going to replace the streaming API called webhooks. Yeah, it's because I've included like MXNet and like GPU stuff, and you know, there are ways to make this much smaller. So Dinero is like 2 GB Docker container, lol, huge. And they're exactly right. This is not the way to do it. And I don't actually, I'm just going to say Twitter account activity. So there's this account activity API where you basically sign up for a webhook, and you can have a webhook hosted by API Gateway that triggers a Lambda function. So I have this, so push, or sorry, I need to like tag this image. I don't even know which region I'm in. So nor rocks. We could do a huge portion of this directly in Jupyter, and we could actually, everything that you've seen so far today, we could have done entirely in the Jupyter instance. But this is actually bringing, what I'm trying to show today is how you can bring your pre-existing models or your own images into your own inference serving images into SageMaker, and have it kind of do the auto scaling and like loading different models and testing different models for you. So that's why we're doing most of this locally today. And I'm actually logged in to the wrong region for ECR. Well, here. This is fine. We'll keep it all in US East 1. So then I need to do create Docker tag body, or sorry, Docker images. Ugh, too many images. Body bot face. So 1.8 gigs, no big deal. Docker tag body bot face latest. That's not even right. I need to figure out how to upload an image really fast. I barely remember. Maybe it tells me in the documentation. Hopefully it does. Packaging and uploading your algorithm to Amazon SageMaker. So let's see, Docker build-t, Docker tag, body box face, latest. So I think I need to do AWS ECR describe repos. So I'm gonna do, I'm gonna say AWS ECR create repository repository name, and Born to Reborn asks, am I live? I am indeed. And I'm gonna call this body bot face. In what scenario would anyone other than like live name something body bot face? So we're gonna create the repo, and then we're gonna say AWS and then I have to like take this whole shindig here, and I need to say Docker tag body bot face. Did I even spell that right? I wish it had tab completion. I think I need to do the latest. And then I'll say Docker push body bot face. Nope, that wasn't right. Docker push this. And this will take a second. And it'll upload everything. Sorry, I'm fading fast. It is almost midnight here on the West Coast, and I did start my morning in Boston at 4 a.m. So it's been a very long day for me, and this is our third little set of broadcasts. But the way that these webhooks work is essentially I create an API gateway, which I have already done. So I'm just going to use the existing one. We're working on a couple different things in parallel now, and unfortunately, just because the other sessions are starting, I am going to have to end my session fairly shortly. And Sinocron asks if this is an official AWS broadcast, and while they may not admit it, I am an AWS employee, and it is an official broadcast. So thank you guys for joining me for today. I appreciate you taking the time. I hope it's useful. Watching me flail around with our various services. What's ridiculous is I actually have 1 gigabit per second up, and it's still taking a while to push all of this. So I have this api.ramman.com kind of shindig going on, and I have this Twitter 2 proxy integration, which calls out to a Lambda function. And that Lambda function, so basically what Twitter will do is whenever an action happens on the @whereml account, Twitter will trigger this webhook, and it will post the contents of that over to my endpoint here, which will trigger my Lambda function. Or it doesn't even necessarily have to trigger a Lambda function. I could trigger a push into, the not safe for work function. Actually, what it does is it uses the recognition content moderation library. So we have another API called recognition, and all it does is it just says, is this image, does it contain something that it shouldn't contain? So I called it an SFW. We actually built that on a stream, on a Twitch stream a few months ago. So going back to API gateway here, I'm actually going one more back than that. It's interesting. Well, I feel like my entire computer and brain and everything are kind of running slowly now. It's been quite a long day. And you guys are welcome to use any of these things, by the way. All of the code I will post later today. And I will put it in a repo called BodyMakeBotFace just for you guys. But what it does is it kind of calls out to this, this Lambda function, and all the Lambda function does is it sort of processes that that input and does stuff with it. And this doesn't necessarily need to be a Lambda function. Like I could have this easily just go straight into Elasticsearch if I wanted by doing a body transform on the JSON. I could have it call out to step functions. There's a bunch of different stuff that I could just like automatically import all the Twitter data. But in this case, I actually want to be able to like push back out to Twitter. Hi, WS Ubi, thanks for joining the stream. Pardon me. And Sinocron asks if I pay for AWS services as an employee, and for things like this, I do not. For kind of personal stuff, I do have to pay my own bill. That said, being able to like experiment and play around with stuff is a huge perk of working at AWS. Pardon me. And one of the core tenets at Amazon is be frugal. So everybody's encouraged to kind of be frugal with their usage of the services, because you don't ever want to like consume resources that would be better serving customers, stuff like that. that is like the corporate kind of leadership principles that we all sign up for. And one of the cool things about Amazon is that people actually follow those leadership principles. So the way that we create a webhook is we basically just say account activity /all. We post the webhook URL, and then I'm actually keeping my parameters over in SSM. And SSM is Simple Systems Manager. So if I go import Photo3, SSM equals Photo3.client, SSM, I can say SSM get, let me turn off this stupid image, sorry. SSM dot get parameters, you know, and I can do whatever I want there. Get parameters. So in this case, you know, I have the ability to kind of create an authenticated session from various Twitter accounts that I have, and I keep all the data in SSM. And I'm actually happy to give you guys AWS credit if you just shoot me an email. randhunt@amazon.com. That's my email. Just tell me a little bit about what you want to do with those credits, like what you want to build, kind of like what experiment you want to run, and I'm more than happy to shoot you over like some credits to experiment with and try stuff out. WS Ubi asks what this is for, and what this does is it allows you, a couple tweets here. You can post a picture of a place and it will guess where that place is. So people are posting pictures now, and it's guessing where in the world those pictures are. And we actually already kind of like played the, oh, I like that GIF. That's funny. Wrong. And it said that this was in DC. I'm actually surprised that it even responded to you there. I didn't even know that it worked on GIFs. I had not tried yet. And I just love going through this, and I actually collect all of those. I grab all of those images, and then I try to retrain the network if I can figure out where they are. You need a batch of like a good 100 images to actually continue training the network, and you have to make sure it doesn't regress. And when you do all of the cropping and the transforms and stuff, you run into various issues. But I'll just really briefly show you like what the Lambda function should look like, just because we don't have a lot of time left. And I wasted all that time kind of setting up stuff. So the way this should work, the way this should look is you basically say, def lambda, function, event context. I am really, really tired. And then we say, if valid record event, then, if not valid record event, then we want to like end the function as quickly as possible. 1, 2, 3, 4. So we return. If it is valid, then basically we say, build a tweet, kind of like download. So we basically, we go up here, import photo3, we say photo3.client. And we're going to say runtime.sagemaker. And I'm sorry that some people don't like Vim. It's actually the greatest editor of all time. And if you don't believe me, there's a really great website that allows you to vote on the best editor. And we coded this live on Twitch as well. And you'll notice that Vim is winning by a healthy margin. And just because I have control over all of this, we're going to make a quick change here. Because I don't think 309 is a healthy enough margin, so editor votes. Where's Vim? So, come on. Seriously, it's not letting me edit it. Okay, well, I'll edit it later. But 309 is definitely not enough. There needs to be way more. So basically, we call out to SageMaker, and I'm just gonna call this SM, and we say sm.invoke endpoint, predict or body make bot face, and then we pass in our body from the event, which is going to be like the media URL. And I just don't have time to like finish the rest of this, but that is how that is basically how it all works in the end. And then you just do Twitter API, twitter.post post update, and then you put the result of that invoke endpoint. All right, so thank you guys so much for joining. There are a few other sessions that are happening right after this, not on Twitch. They're back on the main page for the Innovate conference. So I'll post that link one more time for those of you who aren't checking it out yet. And in general, machine learning is not that hard. I think SageMaker makes it a lot easier to get started and kind of play around with it. The code, we can post the code right now as it is, and I can add more later, but we can say hub create. And I'll say get add Dockerfile, get add app, get add predict, get add, and I'll add grids.txt too, and then get commit-m. Thanks so much, Twitch, for your help. And then get push. Actually, I'm gonna do get commit-mend. Who wants to be named in this? So Dunero was very helpful. JFM Mario wasn't helpful, but was funny. Actually, you're pretty good. The Chad 314. Anybody else want to be named for all of your help here? Noor Rocks. Amar Fayaz. Sonus Singh Hall, WS, Ubi, Punkiz. And Amar gave the name, so definitely, thanks for the name. D Harsh 4. And anybody else? Okay, I'm adding random people at this point. Anybody else who the 40. Anybody else who wanted to be in? You lost your chance. I'm gonna close it out now. Thank you all so much for your help. Get push origin master. This should be open now. So you guys can go and look at the code. I will update it later with like the working Lambda function, among other things. You're all wonderful, and I appreciate you kind of taking the time out of your day to join the session. I do live coding on Twitch fairly frequently. I've been on the road a lot recently, so I haven't been doing that. I hope you'll go back to the other Innovate sessions. Kind of, this is quite different from many of the other sessions. Many of the other sessions are pre-recorded, and they don't make mistakes because they're kind of polished and they have time to like really do a presentation. But I think it's always super useful for developers to see how someone codes something without a lot of preparation. a lot of times we're working and we're debugging things live, and it's useful to kind of share that experience and share that process of building that we all go through but don't necessarily ever expose the rest of the world to. Again, thank you very much. It's midnight here in Los Angeles, so I'm going to go to bed. Everybody have a great rest of your week. Thanks again. Bye. Oh, and follow me on Twitter. This is my Twitter account, JR Hunt. I always talk about serverless and get in trouble. Bye, everybody.